Hello, so the purpose of this video is to help clarify some of the terms when we're doing one sample tests, looking at mu's and looking at S bars and S sub X bars and all those fun things. So try to make it a little less so that it feels like it's all Greek to you. Alright, so remember that the whole idea is that this is coming from the idea of doing inferential statistics, where we can take a subset of a population called a sample we can pick out the sample randomly choosing from a greater population, and we can make inferences about our sample back to our population. And that's what's really important, is that I can look at a small group of, say maybe we have an N of 30, N equals 30, and I can make inferences back to a population of hundreds or thousands. And the reason I can do that is because of something called the central limit theorem. The central limit theorem has essentially two major components that if we randomly select our members of our sample, we know that the mean of the population will be essentially equal to our sample of the population, and the standard deviation of the population will be essentially equal to the standard error of our sample. And those are two very critical points to being able to kind of give us the right to even do inferential statistics. But we need to kind of clarify, okay, so what are these symbols that we see here? And that's what we're going on to the next slide. So when we have a population, when we're looking at population mean, that's when we're dealing with the Greek letter mu. When we're dealing with the sample mean, we're dealing with an X bar. When we deal with the standard deviation, we're using the Greek letter sigma. When we're doing a sample, or population standard deviation, when we're doing a sample standard deviation, we just use the lowercase s. And then when we are doing a population standard error, we have sigma sub X bar. When we are doing a sample standard error, lowercase s sub X bar. And remember, standard error is always going to be calculated by looking at the standard deviation over the square root of n. So for a population, or for a z statistic, we're going to need s sub X bar, or sigma sub X bar, to be calculated by sigma over the square root of n. Where for a t statistic, we're not going to know sigma. So we're going to do s, one second. We're going to do this s, not s sub X bar, s divided by the square root of our sample size, and that's how we get s sub X bar. So, using those terms, when we want to compare a z-test to a t-test, a z-test, we know our sample, we know our sample standard deviation. We also know the population mean, and we know sigma. So our z-obtained statistic, or our test statistic, is going to be our sample minus the population mean all over sigma sub X bar. In a t-test, or one sample t-test, we know X bar. We always will have our mean and our sample mean and our sample standard deviation. In this t-test, we do know mu. We don't know sigma. So since we don't know sigma, we need to estimate sigma by doing, sigma to estimate sigma sub X bar by calculating s sub X bar. So what we need is s sub X bar, which we can do because we have our standard deviation and our sample size, or our n. So the t obtained is a very similar formula where you're still doing x mean or r mean or sample mean over minus the population mean, but instead we are subtracting by s sub x bar, or the sample standard error. So hopefully those slides will help clarify some of the differences between a Z1 sample test and a T1 sample test, and help you as you prepare for your exam.